Hello, good evening, everyone, and welcome back to another virtual science camp. This one is going to be the first one on money laundering. Money laundering, well, first of all, €1 science, the whole idea behind this one is in a lot of the virtual camps so far, like in the spring sessions, we were often using coins, like to weigh things for the Newton meter. I think we made paper bridges and we were using them as weights. We measured surface tension on them. So I thought, wouldn't it be neat to have a series where we're just looking at money and mainly looking at coins? So today we're going to look at how to clean money, but just as kind of like an exciting demo to lead into that, I'm going to show you how to burn money without really burning it. So this is one I didn't tell you to prepare the materials to do at home. I don't want you attempting this at home unless you're directly with an adult who's okay with you lighting things on fire. Sometimes people don't like me recommending that young people light things on fire. So definitely don't say I just told you to do this. I'm recommending don't try this at home, even though I don't find it all that dangerous. Here I have a bunch of bills of money. Oh, and I'm going to stop sharing my screen because you don't need to see that anymore. Okay. And just going to spotlight my video. So if you don't yet see me in big, because you can switch between gallery view and speaker view, I'm going to recommend you go to speaker view to see big when I'm showing you things. So if you go up to the top right corner, like near the corner, and you can switch between gallery and speaker view. So now I have a bunch of money. Surprisingly, I don't have euros with me right now, but they're more valuable than I want to try burning. I have a bunch of things that are roughly equivalent to €1. And those of you in France know that we don't have a €1 bill. Here's an American dollar bill. This one, if you can see it up close, it's actually from San Francisco, which is where there's the Exploratorium, the world's best science museum. And so I keep that as a sign of good luck. Can anyone either shouting out or writing in the chat, let me know if you can identify this guy on the Serbian 100 dinar note? I'll give you a second to respond to that. Does anyone recognize this money? Hopefully some of you will be able to.
Turkish lira.
Exactly, Turkish lira. So I even have some Turkish lira we could use. And there was, yes. Oh, sorry, I didn't notice the hand raised there. But yeah, that was Turkish lira. And this is Ghanaian cedi. And we should, depending on his internet connection, be joined by at least one teacher from Ghana. But I don't think he's here yet. So Ghanaian cedis as well. If anyone has a great preference which one I use for this demo, let me know and I'll use them.
So we're gonna burn some money?
Well, I'm going to burn it. You're not going to burn it. So I'm telling you, don't do this yourself. But I'm going to burn money without actually having it be burned. So it'll be on fire, but it's not going to be burned through the magic of science.
Okay.
Because it's science, I'm going to start with Nikola Tesla. So he's a very good scientist. Hopefully you guys have heard of him. He's most famous for developing alternating current, also most versions of the electric motor that actually worked well, but not absolutely everyone. And what I'm going to do, I'm just going to dip this 100 dinar note, which is worth just under €1. It's like 90 euro cents. And I'm dipping it in a mix of ethanol and water. And that should be fairly big on the camera there. And what I'm going to do is light it on fire now that it's in that mix. It's a bit of a blue flame. Hopefully that shows up on camera. And I'll repeat it with the lights off so you can see the flame a little bit better. But I was on fire, yet the bill comes out perfectly intact. I'm going to repeat that again with some Cambodian money. And turning the lights off so you won't see too much. Well, it's nice and dark here.
What did you put with the water? What did you put with the water?
With ethanol. So it's a bottle of ethanol that's 90%. The other 10% is going to be water. And I just mixed that with a little bit of water so it's not pure ethanol. And this demo can work with pure ethanol. It's just sometimes the bill will actually go up in flames, and I want it to actually work well when I'm showing you. So now it's a little bit darker. You might not see the ethanol as well, but hopefully the flames will show up a little bit better.
Oh.
And we can see it's not country specific, right? I just burned Cambodian money there. And let's go to my lucky Ghana cedis. And as long as the whole thing is wet, then as it's on fire, I'm going to hold it up a little bit higher so you can see the flame a bit better. As it's on fire, then to burn, the ethanol actually evaporates. I keep dropping it because it's kind of hot on your hands. But I keep, as it burns, the ethanol evaporates. Oh, that just singed it barely at the end because it was folded after I dropped it. But when the ethanol evaporates, it actually cools the bill enough that it can be on fire and not actually catch on fire. So evaporation, a cool use of science so that I can look like I'm burning money, and most of the time I don't actually burn it. Any questions on that one before I move on to the experiment where you guys will actively be doing something rather than just me demonstrating? Okay, and some people thought that was cool, so I'm glad some of you appreciated that. So now we're going to get to actual cleaning money. So not just burning money, so cleaning it. I recommended that everyone have 1 to 5 cent euro coins, or in Turkey it should be, I think, the 1 kurush coin that's made out of copper. So just to show, they should look a variety of colors kind of similar to this. Yes. Oh, so the burning money demo, that's an excellent question. It should work pretty much fine with normal paper. It doesn't work quite as well just because paper doesn't, like regular paper, isn't as absorbent. Money, depending on the country money's from, often it's a weave that has paper fibers mixed with cloth fibers like cotton. So it'll wick the ethanol a little bit better. But that being said, unless you're like unlucky, it'll work with normal paper as well. If there's time at the end of the session, or if anyone wants to stick around afterwards, I'm happy to demonstrate that for you guys, because that's kind of a cool line of thinking. But I won't bother now because I want to get into the part where you guys are experimenting. There's another question. Oh, Gabriel, you seem to have your hand raised.
So wait, what I was gonna ask? Oh yeah, I already did like with the type of alcohol that you have right here. I did it on my hand, like there was fire on my hand.
And so you know firsthand that the evaporation makes it so as long as what you have is under the flame, then it shouldn't be getting particularly hot, right?
Yeah.
And that's a trick I was thinking of showing you as well as a follow-up to that, but it doesn't directly involve money. And if you're an adult and you have hair on the back of your hands and you haven't recently burned it off in an experiment, then it actually hurts because it burns the hair, even though the skin is perfectly fine. So it's one that actually is easier for kids to do than adults. But again, don't do that on your own unless you have someone directly supervising you. And don't tell them I told you to start lighting your hands on fire. We seem to have a question from Zainab. Yes, please go ahead.
First of all, I'm sorry, my English is not that understandable, but some fire shows that making for amusement is making by using ethanol, right?
Yeah. I mean, it depends what the fire show is doing. As you noticed, when I burned it, ethanol had a bluish flame that doesn't show up that well if there's much other light. So if they're trying to make flames that are like big and yellow or orange that are really like flame-like, they might use something else. But ethanol is commonly used in a lot of like different fire things if you're intentionally lighting a little bit of fire for one reason or another.
Thank you.
Going into the experiment where you guys are going to be washing coins. So you should have several coins that are various stages of dirtiness. As long as you didn't go to like a bank or a mint where they make the coins, if you have copper coins, some should be dirtier than others. So you'll want to select a couple of the dirtier ones. And to go over the experimental method, I'm going to share my screen again, because these will be a couple of steps. Once I put you into breakout rooms, you're going to be kind of on your own, like you'll be in smaller groups, but you won't have me there guiding you through it. So these are the steps that you'll have, and these will be available in the Google form where you'll be entering results. So once you're in the breakout room, of course, try and introduce yourself to the other participants. If you're able to with your microphone or your camera, that's the best. But if not, at least in the chat, say hi or something so they know you're there. Then everyone should choose one sauce or condiment to use. So I think I said
like,
choose.
What kind of sauces?
So whatever you find around your house, but on the form I made, I think I listed ketchup, mustard, soy sauce.
Oh yeah, like sauces. Like okay.
And if you have no sauce and you at least have water, we want one person to use water as a control. So you can just use water. Hopefully everyone has water. Also salt and water and salt and vinegar. So there's a couple of ones I've already listed. But if you have anything else you want to test, there's an other category for the results. So write in anything else, because it'll be good to get anything that's interesting. And the experimental method for that, so I'll demonstrate with the ethanol cup. And that's not one of the ones on there, so we say other. I'm going to choose a coin that's fairly dirty and just dip it halfway in and hold it like that for about 3 minutes. And the reason only half of it's going to be in is so that when you take it out, you should be able to see a clear line where part of it is cleaner than the other part. And that way, it's independent of how dirty the coin was in the first place, how it looks afterwards. You're looking for the difference in the two halves of the coin. Does that make sense? Okay, and I'm going to add a link to skipped a little bit ahead to the explanation. So there's a link on my screen share there, and I'm gonna put it into the, I'm gonna stop sharing my screen so I can put that into the chat and you can go directly into it. Just a second to cut and paste that. And so that just gets to a Google form where it goes over the steps again. So if you forget the steps I told you, you'll see it written there. And then you select which sauce you used, and then you'll rate whether the coin was no cleaner at all, perfectly clean, a little clean, or fairly clean. And hopefully having about, I don't know, 15 of us here, it's hard to count, but hopefully we'll be able to get a couple of results from that. And you'll have about 10 minutes in the breakout room. So if you work quickly, then you should hopefully be able to get 2 results each. Maybe if you really push it and you leave it a little less than 3 minutes each, you might be able to get 3 results. But just try and get a couple of results so we can discuss the results afterwards. So a link is about to come on your screen that'll invite you to join the breakout room. Again, if you haven't been in breakout rooms before, so those of you who were in my spring sessions, you'll probably remember how this works. A lot of you have used Zoom and other contexts as well. But just to recap, once you enter the room, it's like a smaller room. This time there will be 5 of you invited to the room, or like the nearest number rounded to 5. And you'll work together with that, trying to coordinate. So hopefully no 2 people in the same room are using the same sauce. Because I'm not going to be able to be in all the rooms at once, you'll be without me for about the 10 minutes this lasts, and then we'll get back to the main room again afterwards. If you need help, there's a way to send a help request through the chat so I can enter your room after that. Takes about 10 seconds to switch between rooms, so don't worry if I'm not there immediately. I will get to you eventually. Are there any questions people need to ask before I send you into your breakout rooms?
I did it.
You did the experiment already?
Mm-hmm.
Excellent. Then you can already start adding results and just let the people in your breakout room know.
I did them the results.
Okay, because the more results we get, the better. So yeah, that's excellent. Okay, and so you have a link now, or it should be appearing very quickly. Okay, sorry that took a minute. Okay, now you should have a link to all the breakout rooms, and we'll be coming back into the main room after 10 minutes of experimenting. Okay, perfect.
Good. Thank you.
Okay, so everyone should be back in the main room now because the breakout rooms have closed. It looks like we lost a couple of people, and throughout the breakout rooms, it seemed that some people had disconnected and reconnected, so had some problems with that. Can everyone, if you still have any results you are finishing up, make sure you enter those in the form. And before talking about those, I'm going to show you guys the results we have. Can you guys let me know if you experienced any particular problems with the breakout rooms that I should try and plan around for future sessions?
There was a lot of breakout rooms. So I wasn't in the same one as well. We were in different ones, yes, but I was in a breakout room where there was nobody.
And for some reason, it didn't seem like everyone actually joined the breakout room they went to, and it seemed like some people left the meeting. So I tried to shift things around when that happened, but maybe that didn't work out so well for some of you. So I'm sorry if that didn't work out as well as it could have. Please let me know if you have any other feedback about them.
Maybe you should do less breakout rooms, but if not, it was okay.
Yeah, I'm thinking it might be best not to do them too much. It's just always seems like it could be a good idea to try and get people more talking to each other, but it doesn't always work out as well as I hope sometimes. So I'll keep that in mind for future sessions. Okay, getting to the results of the experiment, I'm going to share my screen to show you the results we have. So we don't have all that many results, but we've got 7 different results in. And we can see a couple of different things were tested. So we had vinegar tested by a number of people, soy sauce by some, water only, mustard, and olive oil. And it'll be interesting.
Oh, vinegar wins.
Vinegar wins? Oh, now we have an 8th result. So here, these aren't yet linked. So we're going to go to a spreadsheet so we can actually see the results. And we don't have all that many results. So just looking at the numbers, we can get a pretty good idea. But one thing we might wonder is what we would do if we managed to get a lot of results for this. Like if everyone had gotten 3 different results and was able to add those, then with like 15 or 20 of us, we'd have 60 results. And that'd be harder to see. So Alex is saying soy sauce wins, and I think Gabriel said vinegar wins. So let's look
at anyway, one of them wins.
One of them wins. So what I'm going to do is I'm just going to...
I'd say vinegar wins. Because there's more vinegar here than soy sauce.
Okay, and so vinegar was tested more. But if we look at the results of the test, we had very clean, as clean as new, which is the best one we could get, and as clean as new with soy sauce. So in the very small sample size we have, which is too small for us to say for sure, then soy sauce 100% of the time got the coin looking as clean as new.
No, the second one said slightly cleaner.
Oh, I totally missed that result. It's a good thing that you were paying more attention than I was.
And the other vinegar, there was much more.
Okay, whereas vinegar, the minimum it got was very clean, if not as clean as new. So we'd say vinegar seems to be the best one we've tried so far, or vinegar plus salt. And Does anyone have any suggestions why these results might be as they were?
Acidic.
Acidic, excellent. And that might have been Arda, because I think you were saying in the breakout room that you'd done some research.
Well, that's a clean one.
So it turns out acids are really good at dissolving oxides. So what happens when the coin goes a darker shade of brown? When it's new, it'll be like a clean, shiny copper type, like the clean part of your coin if you got it clean. And when it's left exposed to air over time, it gets a lot darker, right? We have like the darker, and the difference between that is that the darker one, it's actually absorbed oxygen. And it's a couple of different kind of complicated chemical processes that can be catalyzed by a number of different things. But just over enough time, having anything made of copper, it'll eventually build up a layer of copper oxide. And I'm going to share my screen one more time just to go over the chemical equation of what's going on there. We're low on time, so I'll go over this kind of quickly. Screen share. Okay, so you should see two equations I've put up there. I'm just going to make this bigger so we can see it nice and big, hopefully. Okay, so we have copper oxide plus vinegar. Vinegar is acetic acid. That's just like the chemical name for it. And so acetate is what we get when we take the hydrogen atom or the proton off of it. And it undergoes this chemical reaction. So it actually just forms water and copper acetate that stays in solution. If we look at the chemical formula of that, we can see that the O from the copper oxide ends up going with the H from the acetate. This CH3COO is the acetate part. And it dissociates with the H as an acid. And that's something that all acids do. They have free hydrogen. And so any acid would work for this. It's just acetate, well, so I'm forgetting the chemical name for vinegar. Acetic acid is common in a lot of foods we have, so it's a common household one. And it'll form this in solution. We can test that it's in solution if you take another piece of metal, like a paperclip, and I think I recommended you guys have a paperclip. This can also be done with a nail or any other thing made of iron or steel. And if you put that in a vinegar solution, it's probably best if it's pure vinegar rather than your condiment. But if you put that in a vinegar solution with a coin, copper coin, you'll get the copper plating onto that. And it'll take about 15 minutes. So that's something you could leave afterwards and you could check it to see you should have a layer of copper on your paperclip. I think to be, another thing about this method, if we added salt, and a lot of the condiments like soy sauce has a lot of salt in addition to vinegar, the salt actually speeds up the reaction. The way it does that is it has chloride ions that kind of keep the copper busy. So it can form copper chloride in solution, which helps keep the copper away from reforming as copper oxide, and the vinegar works a little bit quicker. But if you leave that without rinsing it afterwards, then you'll actually have a green layer that forms on it. And that'll be copper chloride or various oxides of copper that's catalyzed by that. And you'll notice that like old statues are green. I'm going to show you an animation of the Statue of Liberty. And it's an approximation of what it would look like or what it did look like after several years of age, because it's made of copper. And as we see it now, because it's been outside for like 140 years, it's the green color of copper chloride, which it gets from salt from the salt air by the sea. Does that make sense for the chemical reactions of what we're looking at here?
You can ask something. If in the New York they start the rain acid rain, it will return copper color.
Wait, can you?
Can I pause the image?
What is the first? What is the first color of the
Oh, the first color is like the shiny new coin. But to get to the other question, will acid rain make it go back to the shiny color?
It passed directly from shiny orange to red.
Yeah, because that's copper oxide. If it's a thin layer of copper oxide, the red, it's not going to be like red. It's going to be like a darker brown. Like that red's probably not a great approximation. But to get to the question about acid rain, if the rain were acidic enough, then it could get it back to the original copper color. But the thing is, if you leave a coin with acid on it, especially if there's free chloride ions around, and because the statue's by the sea, then it'll get a lot of chlorine from the salt from the sea, then the acid is going to catalyze the reaction making copper chloride or more copper oxides if it's in the air. So if the acid rain completely covered the statue and was wet and not exposed to the oxygen in the air, then it would make it like brand new copper. But if it washes off and there's some acid residue mixed with oxygen from the air, that actually brings it like straight to the green color. And that's why over a number of years it goes to the green color. And that green color is less reactive than pure copper. So it won't, and less reactive than like basic copper oxide that's the slightly brown coin. So it won't wash off as easily. But yeah, if they washed it with strong acid or if it was completely immersed, it would go back to a pure copper color. I really like that question.
Thanks.
Can I ask a question?
Sure, yeah, of course, go ahead.
I used soy sauce while doing that experiment, but my sauce was less salted, so I think it affected the I don't know how to say.
Like it affected the results.
Yes.
It definitely would. And soy sauces will vary enormously on their vinegar content. Like when you consume soy sauce, you'll notice it's not as sour as pure vinegar. And often it's about 1 or 2% acetic acid, whereas most vinegars, varies country to country and the type of vinegar, but typically it would be about 4.5 to 7 or even 8% acetic acid. So soy sauce won't be as strong in vinegar concentration, but it varies. And then the salt concentration will vary as well. So there's not just one kind of soy sauce that'll always work. Okay, because we're out of time, and I can stay later if people have more questions, and I'm happy to answer more questions, but I want to give the opportunity for anyone to leave if you don't have more questions and want to go. I'm going to leave everyone with one challenge that I didn't address at all in this session, but something interesting you could play around with. And that's, how can you clean up bills of money that are dirty? So I have some bills that are dirty, like cleaning coins is one thing, but cleaning bills is different. And if they get wrinkly, how can you make them straight and flat again? And if they're dirty, how can you make them clean again? So that's something, like, I don't want you to try and answer now, but if you can think of any experiments to try and do that at home, then I'd be interested in hearing what you get to try and clean bills of money. And on that note, like with that final question to leave you guys with, there's something in the chat.
Well, Alex said iron them. That might work.
Oh, okay. So that's one thing you could test. Anyways, because I've gone 5 minutes over, I just want to say thank you to everyone who came. Again, if you want to stay after, ask more questions either about what we did now or for a different session, feel free to. But this will be like the official end for anyone who's not staying after. So thanks for joining again. Have a great evening. I hope to see you in Saturday's one on testing face masks. And don't forget to stay curious. Have a good evening, everyone.
Can I ask a question?
Yeah, of course.
I want to attend the mask experiment too, but can we use used masks? Is it okay?
Oh, yeah, that's a great question. Those would be perfect, yeah.
Okay, thank you.
And actually, especially if you're not using reusable masks, used ones are better. because one of them will be getting the masks a little bit wet, and you probably wouldn't want to use a disposable one after that, and it's a waste to just use it for the experiment. So yeah, used masks are even better. I'll add that to the document or to the email I send out with the link, because that's a great point I didn't think of mentioning. Thank you for bringing that up.
I didn't get the link with the experiments.
Sorry,
These
can you repeat that question?
I didn't get the what do we say? I'm not sure it's a link, but I didn't get what are the experiments that we're gonna do?
I have a list.
For Saturday's session on testing masks?
Okay, yeah.
Like, is that your question? What are the experiments we're going to do on Saturday?
Yeah.
So I don't think I went into a lot of detail into the different things that we're going to do. I can go over like a really quick summary, but like I'll wait until Saturday to go into most of the detail. But we're going to do a couple of simple things to look at. First of all, what do masks do? And like, it seems obvious to ask the question, what do they do? But the two ways that they're effective primarily are by stopping water getting through, water droplets, and by stopping air getting through. And so we'll do a couple things to demonstrate that small droplets of water can't go very far on their own because they're close to their terminal velocity, so they need to be carried on air. Then a simple one to see what size of droplets could get through what size of mesh in a fabric. And then how fast air can leave, like when you blow out, or potentially if you sneeze or cough, but like we'll model it just blowing, because that's one thing it's easy to measure rather than like trying to get everyone to cough at a similar strength. And we're going to see how that's affected by different things you can put in front of your mouth, and like how we can test that. Hopefully that's enough detail for what we'll be doing. Oh, and I think in the description, I'd said that I'll be sending instructions for making water-sensitive paper. My tests for that haven't worked out well enough that I'm confident it's easy enough for you guys to do at home. So I'm probably going to say, don't bother trying to make your own water-sensitive paper. Like I can get it so it works for me, but to the point that it'll work every time that you guys do it, I don't think it'll work well enough. So I've changed, I'm in the process of changing what I'm planning on doing. So you won't need that for one of the tests.
Okay, thank you. Thank you. Thank you.
You're welcome. Does anyone have any other questions before I end the session? Okay, I don't see any in the chat either. So thank you everyone again for joining us.
Thank
you. Great
you.
having you along. And
Bye.
have a great evening, everyone. Stay curious.